So if we're here and we click enter, if I'm meetup50, if that's my user, and I click enter, my password is meetup-50. It's whatever your username is. All right, so I am meetup-50. Everyone else should be their username. And then you should get to this screen. All right? If you're not able to get to this screen, please raise your hand, ask your neighbor. Let's collaborate right now so we can all get to this point, please. All right? And let's hit the front lights. Talk it out.
Yeah, so I continued with my it's a fintech company called Spitfire. I don't think your cohort was but the previous ones. Yeah, cool. Yeah, there were 3 guys before me. 2 of them are still there. One from like 2 years ago, one from like a year ago. Same full stack, mostly back end. Things going on, so sometimes they work on Django, sometimes they work on
What do you do?
Sorry to jump up here.
Slack channel?
Yeah, a few people are still lost, so I thought I'd just put that up there. Yeah, I think that's right.
Alright. Yeah, I've totally forgot about that, actually, sorry.
That's all good. I think there's only like...
Is that it?
Yeah, I think there's only 2 or 3 people who are still 2K, Z, E, A, F, R. Yep, that's it.
Alright, cool.
Yeah, there's only like a couple of people who are still.
Alright, sweet. Alright, so is everyone good? Give me jazz fingers if you're good. Anyone not throwing jazz? Alright, we're cool. Alright, we're all good. Apparently this is the Slack link if you didn't get it before. Instead of putting it on here, why don't we just put it, oh, you can't put it in Slack because you need it for Slack. Could write it on the whiteboard. I'll do that later. I'll put it in Meetup later for this Slack channel. Okay. So now that we're all here, so before we can really talk about Linux file permissions, right? We have to understand the different types of files that are in Linux. Okay? The first thing that we need to understand is in Linux, everything is a file. I know that sounds weird, right? But it's true. Everything is a file in Linux, and there are basically 3 different types of files in Linux. We have ordinary files. Ordinary files are things like text files or your computer programs, your Ruby or Python or JavaScript files if you're using Node, or like MP3 files or images. Those are all what's considered ordinary files, okay? We then have what's called special files. Special files mostly deal with computer processes or the input from hardware, things like that. It's how processes talk to each other, or it's how it's receiving input from outside sources and keeping track of that input. Really, we don't run into special files in Linux. The only special file that we'll normally see in our day-to-day operation is something called a symbolic link, which is a special file in Linux. And we're actually going to create a symbolic link and talk about that a little bit more. All right? So that's a special type of file. And the third type of file in Linux is a directory. All right? And basically, a directory is just a grouping of files. Right? So everything in Linux is actually a file. Also, if I ever am up here and I'm just speaking pure trash, and some guy's like, no, 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 that's not what that is, feel free to chime in. All right? No, it's all cool. It's all cool. All right, so we should all have the same file directory, right? So let's take a look at what we have. So we're going to do ls-l to print out all the details of our file directory that we all have. And we should all have the same one, okay? Now there's a lot of information here. Whoa, ninjutsu class starting up. Missing that one. All right, so there's a lot of information here, and it seems a little weird to us right now, but we're going to go through each and everything. So the far left column, this far left column that we have here, this denotes what type of file it is in Linux, okay? It denotes what type of file. If it is a dash, that is an ordinary file. That's just a text file or an image or a piece of script, something like that, okay? If we see a D, what do we think a D might mean? Directory, right? So that is a directory. So we know that that diary and that important right there are directories. The other weird thing that we see right now is this L. That L is the symbolic link. That's a symlink. That's the special type of file that I was just talking about that we're going to explore a little bit more. But this left-hand column denotes the file type in Linux, right? So it's either a dash, which is that ordinary type of file, a D, which is a directory, an L, which is that symbolic link, or there's a couple other letters. There's like a B and a Q, and I think there's a W. Those are special types of files that you'll most likely never run into if you're a sort of full stack programmer, unless for some reason you're taking hardware input or you're having processes talk to each other and you need that to happen in a very specific way. You'll most likely never run into those files as just a pure full stack sort of web developer. Now, if you do different type of stuff with dev, you might run into those things. So the ones that we're going to focus on today are the dashes, the Ds, and the L. All right? Anyone have any questions so far? We all feeling good? Feeling good? All right, sweet. Cool. So now we know how to tell if something is a directory or an ordinary file, but how about the different ordinary file types? Okay? Like, we have this ordinary file here, cat, and it doesn't even have an extension. Weird. Like, how am I supposed to tell what type of ordinary file that is? Is that a text file? Is that a music file? Like, what type of file is that? Well, the really cool thing is in Linux, we have a command called file that'll tell us what type of file it is. Because in Linux, we actually don't need file extensions. File extensions are unnecessary in Linux because what it does is it's like this three-step process, and one of them is actually called a magic function. So basically, Linux determines what type of file it is, literally with magic. So because of this, it actually inspects what's in the file and tells us what type of file that is. For example, if we all type file and then the name of, say, let's do dog.jpg. Let's go dog.jpg, dod.jpg, and click enter. This tells us that it is a JPEG image data, okay? Now, it did not get this information from its file extension. You may be thinking, oh, Garrett, it says .jpg, so of course it knew, right? Of course it knew it was a JPEG. But let's try it on the cat. So we saw a file, let's go file and type it in for cat and click enter. Cat is also a JPEG file, right? So in Linux, we actually don't need file extensions. It's able to inspect what's in the file and tell us what type of file it is. And so we can use this file command to determine what type of file is actually on the system. We don't need the extensions to do it. Cool. Any other questions? I'm going to pause and answer questions a lot. So any questions about this so far? Cool. All right. Awesome. So I want you to tell me what type of file is the shell script file, the diary, and the best Pokemon.txt. Let's go with the shell script first. So shell script. Let's start with Joe, because the way that I ask questions is I just like to snake around, right? And so you're sitting in my top right here peripheral. Just an ordinary file, yeah. But what type of file is our, what did I say? Shell script. If we type it in. Like if we do file shell script, what do we get?
ASCII.
That's right. Oh, I got to type something in. File shell script. Yes, it's just a plain text file, right? So it tells us that this is a text file. What about the diary? Clem, what do you got?
The directory.
Yes. So if we do file on diary, it tells us that it's a directory. How else could we have known that this was a directory, Ari, besides doing file diary?
Starts with a D.
Starts with a D, that's right. So the diary is one of the ones over here that started with a D. So we didn't even need to type in file to do it, but we can if we want to. All right. Best Pokemon.txt. It's kind of an easy one. What do you got?
It's regular file, no read permission.
Okay, cool. So this is a regular file with no read permission. Interesting. So when we had read permission, and we're going to talk about that in a second, we were able to get a little bit more information out of it. But because it doesn't have read permission, it's just able to tell us that this is an ordinary or regular file. It couldn't tell us anything about what's inside of it because it couldn't read it. It didn't have permission to read it, so it couldn't tell us what it actually held. Cool. The last thing that I'm going to show before we move on is obviously doing ls-l is pretty cool. We have a lot of information that we're still going to go over. Obviously, we know what this left-hand column is now. It tells us the file type. But the other thing that we get is this right here, which is how large these files are. This isn't very human readable at the moment, right? You look at it and you go, oh, these are all in bytes. Like, what does this mean? If we add onto our -l flag, if we add an H, we actually bring it up in human readable file size. So we can see that this one's 57K, 56K, and then these are very, very small. Okay? So we can do that -H to make this human readable. Does anyone have any questions thus far about the different file types and how to understand what type of file we're looking at in Linux? Or does it seem pretty straightforward? Not so scary anymore, right? Like it's going to get even less and less scary. Cool.
How come we don't see the file size for most of them? We only see 57K, 56K.
Because these ones are so small that they're in bytes, right? So this is literally 6 bytes or 30 bytes, right? So these are larger files because these were the images, right? And these are just pure text. So they're very, very tiny, right? Yeah, Ellie.
Is there any special meaning for text in different colors?
So a little bit. Obviously, we're seeing the directories being in this blue, right? We're seeing that this this shell script here is coming out in green, and this symbolic link's coming out in this sort of, what color would you call this? Cyan teal. All right, we'll have a fight later to see who wins. All right. So either cyan or teal, someone will win. Yeah. So the color coding, you don't really want to rely on. That's sort of client-based, right? That's sort of like, are you opening this up in Terminal or iTerm or PuTTY, or how are you actually SSHing in? Because each of those are going to have different colors for how we view these files, right? So color coding is kind of nice, but at the same time, it sort of depends on which bash client that you're actually using to see it, all right? So, yeah. Good question, though. Cool. Any other questions before I move on? No? All right. So now we're going to talk about ownership. So now that we know the different file types, we have directory, sort of an ordinary file, and then we do have some special files. What we're going to talk about is ownership. So everything in Linux is a file, right? We all got that. Everything in Linux is a file. Everything in Linux is a
File.
Let's try it one more time. Everything in Linux is a file. Beautiful. Awesome. So guess what? What's this permissions thing all about? Like, why are we here? Well, every file has an owner. Every file has an owner, meaning it belongs to someone. It belongs to a user. And in Linux, we are always logged in as a user, okay? In Linux, we are always logged in as a user. Let's find out which user we all are, all right? So the way that we do that was we type, who am I? and we click enter. And guess what? It's who we logged in as. Everyone's going to be different users, right? So I'm Meetup50, Meetup1, Meetup2, Meetup3, right? So whoever we logged in as, that's who we currently are in Linux. So when we create a file, right? So if we create a file with touch, everyone create a file with me. Everyone touch me, please. All right, so when we do touch, let's do my_file and click enter. All right, and let's look at it. So let's list out L for my file. Let's just look at the single my file here and click enter. You'll notice that this was an ordinary file, right? That dash there, we created an ordinary file, and check it out. It got created as my ownership. This column right here is who owns the file. This is the user who owns it. So Meetup50 owns this my file. Now for you, because you're logged in as different users, it's going to be your user because you created that file, right? So you own it. You own the file because you created it. So that's what this column right here means. That is the owner of this file. All right? Any questions thus far about that? No? Awesome. All right. So ownership of a file is a very powerful thing because it means we're able to do anything that we want with it. For example, if I ls-l here, for example, we have a couple of files in our directory that are not owned by our user, right? We have a couple files in here that are owned by this root user. They're not owned by us. So let's try something out. So if we use cat, that prints out the contents of a file, right? So if we print out cat. So if we use cat and try their file, and we hit enter, what do we get? Permission denied. Right? So now we're starting to dive into this whole permissions thing. Like, what is permissions? What? Huh? Right? Like, why can't I see it? Let's take another file that we do own. So let's try like let's go with the dog one. Let's go dog.jpg. Let's cat out that one. Cool. So that's what a JPEG file looks like. Interesting. Cool. If you get stuck, just hit enter. By the way, if you just get stuck, hit enter. What's up? All good? All right, beautiful. So we were able to read this file. Not very human readable, but we were able to read it, right? We're able to print out the contents on the screen. And that's because we were one of the people that own this file. So in Linux, permissions for a file are broken down into 3 categories and applied to 3 different types of users. Ooh, it's a 3 and 3 thing here. There's a lot of 3s in this. So 3 different types of permissions broken down into 3 different types applied to 3 different types of users. Okay? So let's first talk about the different types of permissions before we talk about the different kinds of users. So as we can see, we have an R. These are the different types of file permissions. We're going to talk about why they are doubled up here in a second. But we have an R. Stands for read, right? That means that this file has read permissions. It means you can read the file. It also means that you can read a directory if this permission is on a directory. You can read what's inside of a directory. We have a W for write. So W means write. That means we're allowed to write to a file. To create or change a file is write. And then last but not least, we have an X for execute. Okay? So just like the name implies, it allows us to execute a file. Mostly these are programs. However, execute permissions on a directory allows us to actually CD into it. If a directory does not have execute permissions, we are not allowed to actually change directory into it. All right, so execute allows us to do that. All right, so we've talked about read, write, and execute, and we're going to play around with that a little bit so we kind of get a feeling for it, what the different ones mean. But now what we're going to talk about are the different kinds of user types that we can have. So the first type of user that we can have in Linux is the owner of the file. An owner, right? The one that created the file. Remember, this is who owns this file. All right? So we have the owner. We also have a group type permission. We can assign files to a specific group. And that group has permissions for a file. That's what this column denotes. This is the group name. This is the group name. So you have ownership, the owner name, and then you have the group name of this file. What group does this file belong to? Okay. Now in Linux, by default, when you create a new user, the primary group that user is a part of is a group of their same name. That's why it looks like a big double up here. And you're like, oh, double up, double up, double up. Like, what's what? Once again, in Linux, when you create a brand new user, the default group assigned to that user is a group of the same name as the user, which is why we're seeing all these double ups here, because we haven't changed anything from default yet. Okay? So that's our group permission. And then last but not least, we have others, which is called the world. Just close that. And that's anyone else. That's any other user who's not the owner or part of the group. Anybody else is other. That's the entire world. All right? So let's break her down. Everyone got this? Everyone got this right here? Actually, you know what? I'll do it on the board. I'll do it up here instead. So what are all these double ups? Right? What does all this mean? This bit right here, that is the permissions. This owner has read, write, and execute permissions. The first three in here, those are the permissions for the owner of a file in Linux. All right? So this owner, root, has read, write, and execute permissions. The next set of three is the permissions for the group of the file. Okay? So the root group over here, if you're a part of that group, you can also read, write, and execute. You have full permissions on this file. So the first set is for the owner of the file. The second set is for the group. What do you think the third set's for? Everybody else, right? The other. So over here, we have the other stuff. Read, write, and execute. So what permission? Let's go with, was that Bryce? No, we're at Bruce. Bruce, what owner permission does this important directory have? This one right here. What are the owners? What is the owner permission of this?
I think it's read write.
Just read and write, right? So we have read, write, and nothing. So we're just able to read and write. Cool. Dan's. Oh, yeah, Clem.
Why would an owner never not have write access to their own file?
Because you might not want it to have access. You might not want it to have execute or write or read access to its own file. It might be something that you want the owner to do something more to be able to access. You don't want it to just willy-nilly sort of change that file. You want him to make sure that like it goes, oh, permission denied. Yes, you can get around that because you're the owner. You can change the permissions, but that is now a conscious decision that you're making to go in and change those file permissions, right? Because you probably took away that permission for a reason. And so you don't want to just be able to arbitrarily write to something that you don't really want to write to. Okay? Cool. Saad.
Yeah, Clem, just adding to that, you might be a white hat hacker who's written a really good malware script. You don't want to execute on your machine. So you turn the execute permission off. Right? Or you've written your resume and it's the final version. You want to just read-only copy. So it's a really good question.
Yeah, really good question. Cool. So then, Nans. The other. What type of file do they? What type of permissions do they have?
For dairy, they can only execute.
They can only execute, right? So they have no read, they have no write. The other group can only execute. I'm sorry, name? David. So for this one, let's go with this one right here. The group file permission for this one. What? They can only read, right? So the owner can read and write, the group can read, and everyone else can just read. Cool? Any questions thus far about that? Yeah, James.
Like, what do you mean by group? Like, what's the difference between group and others?
Cool. All right, so we're going to get there. But basically, as you can see, the group, so the owner of this file is meetup50. The group that it's within is meetup50. So if I, as a user, am not the meetup50 user, or I'm not a part of the meetup50 group, which we're going to do a little bit of group stuff later on, then I can only read. I can't write and I can't execute. All right, so basically it's saying everyone else, right? Like if you're not the owner of it and you're not a part of that group. Good question, though. It'll make more sense the more we play with it. All right? It'll make more sense the more we play with it. Any other questions? Yeah, Nance.
When we create the file, how do these permissions get set?
Cool. So there's default permissions that get set when we create a file, right? So we saw when we created my file right here, what were the default permissions?
It's got read, write, read,
And that's it, right?
that
So
would be the default for
yeah, so that's the default. So when we first create a file, if we don't do anything special in that command, these are the permissions that are automatically going to get assigned to it. This is the owner that automatically gets assigned to it, and the group that automatically gets assigned to it by default in Linux. Yeah. Yeah, Saad.
So when I was teaching at UNSW, right, all our files are still local to all the students. But how we used to control access was through this. So we'd have a group for educators, right? You'd be the owner, and your other were the students. So we'd have answers to quizzes which they could see, but they could never get to, right? We'd have the permission set to read for the group of educators, but nothing set for the others. So they could, whenever you try to access it, it would be denied. So that's where the group owner, etc. comes in really handy.
Yeah, for sure. So let's talk about this file right here, their other file, right? Because we tried to cat out their file before, right? We tried to print to the screen their file. And what did we get?
Permission denied.
Permission denied, right? Because in this, our user, whoever you might be, meetup 1, meetup 2, meetup 3, whoever that might be, are you the owner of this file? Are you the owner of this file? No, right? Are you a part of the root group? You might not know it, but no, you're not part of the root group. Okay? So if our user isn't this one and we're not in this group, what are we considered? Other, right? Is there read permissions for the other group on this file? No, but is there read permissions for the other group on this one? Okay, so we should be able to cat that file out, shouldn't we? Try to do it. Try to cat out their other file. Reading is fun. I thought that was at least going to get a giggle. That's cool. First meetup, yeah. All right, it's cool. So we fall into the other category. So same thing, even if we own the file, even if we own this file, like bestpokemon.txt, even if we own it, we are the owner of this file. What type of permissions do we have on it, John? On the bestpokemon.txt as an owner? Nothing. So even if we own it, can we cat out that file? Can we read it? No, let's give it a shot. So cat bestpokemon.txt. Permission denied, even though we own the file. And it's because we do not have read permission on the owner group. Okay? So owning the file there doesn't really mean jack squat. All right? So the really cool thing, like I said, though, about owning a file is that we can do whatever we want to the file. And that means changing the permissions on it. We can even change the permissions on a file. So the way that we do this is through a command called chmod. And this is where everyone might have seen chmod before, the infamous chmod 777, right? That you should never do. By the way, you should never do. Okay? Let's just get that through our heads right now. Just don't do it. Okay? So there's two different ways that we can say what type of permission that we want these files to have. There's a way called the symbolic mode, which uses a combination of letters and logical operators like equals and stuff like that. We could do it that way, right? But the way that you mostly see around is numeric mode, where we can use 1 to 4 octal digits. So today we're going to use numeric mode. If you want to learn about symbolic mode with chmod, I totally think that you should go Google it and learn symbolic mode, all right? But today we're going to learn numeric mode, which is the infamous 777, right? So there's different numbers that represent different things. Hit the lights for me, Robbie. Sorry. I'm erasing this now. Okay. So, all right. So we have a 4, which means read. We have a 2, which means write. We have a 1, which means execute. And if you ever see a 0, that means nothing. Right? So this is called numeric mode. So we have 4 for read, 2 for write, 1 for execute. Alright? So now that we know this, we can change our file permissions. Alright, lights for me, please. Alright, so let's try it. Alright? So we're going to try to change our file permissions for that bestpokemon.txt file. Alright? So let's try, we want to be able to read it. So let's go chmod 4 bestpokemon.txt and let's see what happens. Because you said, Garrett, that 4 means read. And I click enter. And let's list out the details of this file. ls-l bestpokemon.txt. And yes, we added read permissions. But who did we add it for? Others, right? We still didn't add it for ourselves. We added it for everyone else. So I still can't cat it out. I still get permission denied. Everyone else can read this dang thing, but I can't. That kind of sucks, right? So, wait, we're not the other user type. We're the owner. So if you only set a single number, if we only use a single number like we did, that is going to the other. If we do 2 numbers, it is group and then other. If we do 3 numbers, guess what? Just like it's laid out here, we have owner, group, other. Okay, we have owner, group, other. So if I set the permission to be chmod 444 and I take a look at it, I've given everyone read permission. Awesome. So then, Ricky, who is the best Pokemon?
Let me see. Ditto.
It's Ditto. Yeah, we can argue all day. It can turn into any other Pokemon. How is that not the best? All right? It's just got freaky eyes if you've seen the new Detective Pikachu movie. All right? It can do everything but the eyes, apparently, which is weird. Cool. So, side note, by the way, for chmod, sometimes you see chmod with a 4th digit. You see it looking like this. We are not going to worry about the 4th digit today in this class. We're not going to talk, this meetup. Sorry, educator mode, right? In this meetup today, if you ever want to find out what this 4th digit means, this one right here, I think it's a 0, 1, 2, or 3. If you ever want to find out what that means, please Google it. All right? There's like sticky permissions. There's like set user ID and group ID sticky. We're not going to worry about it in this. We're only going to do the 3-digit set. Okay? We're not going to worry about the 4th digit. Cool. So, awesome. So, basically, what I want you to do now, knowing the knowledge that you know, okay, how might we set both read and write permissions? Because maybe we want to change Ditto. Maybe that's not the best Pokemon. All right? Maybe we've all come to a consensus, and the best Pokemon is by far Gengar, right? Gengar number 1. So, if I want read and write permissions, knowing the numbers that we have, how might we accomplish that? What might the number be? Yeah, Bryce.
6.
A 6, right? So when we want to combine permissions, we just add the numbers, right? So I want you, knowing that it's a 6, I want you to give read and write for the owner, but I want you to give no permissions for the group or others. So I want you to read and write for the owner, but no permissions for group or others. What number would we come out with? All right, what do we got? chmod what? 600. That's right. So read and write for the owner and no permissions for the group, no permissions for other. If we look at bestpokemon.txt, there we go. We can now read and write as the owner, right? Cool. So let's update this then. Now that we have write permissions, let's Vim the best Pokemon. What do we got? Hit I to insert. If you've never used Vim, this is not a class on Vim. I should not have opened up Vim because now everyone's going to be like stuck in Vim forever. Oh, great. Yeah.
Those interested in Vim, I will be doing a little bit of it during next session when we're doing bash scripting.
Ah, yes. So here's Yes, here's a plug for next meetup, by the way. If you are enjoying what we're doing today, James is going to be doing the next one. He is going to be doing bash scripting, so basically how we can take these commands and automate this. And he is going to do a little bit of Vim when we bash script. So who did we decide who the best Pokemon was? Had to be one that's harder to spell. Is that it?
I think so. Yeah.
All right. Sue, what do you got?
When I press I don't get into that mode.
All right. Cool. Aim's coming around. If you've accidentally opened up Vim, okay, hit escape, hit colon, hit Q with an exclamation point. Hit enter. All right. What's up?
What if you would use that game?
James loves it. All right.
It's incredible, and you'll find out why.
Next cohort, found out Vim. All right, cool. So now that we had write permissions, right, and read, I've changed it. I've written to the file. I can now read out the new one. There we go. If anyone's stuck in Vim, please raise your hand so that someone next to you can help you get unstuck. All right. All right. So knowing what we know now, I want you to change best Pokemon so that the owner has full permissions, the group can read and execute, and everyone else can just read it. I'll write it up. I'll write it on the board. All right. There's a script that I use to automate. Bash scripting next week. Cool. So owner, all permissions, group, read and execute, and others, I want you to just be able to read. All right? So owner, all permissions, group, read and execute, others just read. Take a second. Take a drink. All right, Alex, my friend, what is the number that we're looking for? 754. That's right. So chmod 7 for everything, 5 for read and execute, 4 for just read, best Pokemon. And now if we take a peek at it, that's what it looks like. Did everyone get 754? Yes? Yes? You got 754? All right, give yourself a hand. All right, cool. All right. Cool. Glad everyone's super pumped. All right, so now that we're getting the hang of ordinary file permissions, now that we're getting the hang of file permissions on the ordinary file type, next is to sort of explore how file permissions affect our directories, because they affect them in a little bit of a different way. So if we list out our file structure again here, all right, so we can see that our important directory, this one right here, important, all right, so it has the ability to read and write for the owner, read and write for the group, and nothing for others, all right. So really, what does that mean when it comes to a directory? Well, let's try to change directory into it. I already gave you a spoiler. So we're going to try to cd into important. All right? So we're going to try to cd into important. And we click enter. And what do we get? Permission denied. And that's because a directory needs execution permission to be able to change directory into it. You can't cd into a directory that does not have execute. However, what does this directory have? It has, where's she at? Read permissions. So I can still read all the files that are in the directory. So let's do that. Let's read all the files in the directory. So ls-l important. Let's read them all. And oh, we get this crazy little thing with question marks all over the place, right? Cool. All right, so we can actually see what's in here. We can see that there's these 4 important files, file 1, file 2, file 3, and file 4.txt. But because we can't execute in the directory, it's kind of locked us out from really doing anything else, right? It doesn't even matter what type of permissions are on those files because we can't execute inside of the directory. So it's going, yeah, nah, I'm not even going to tell you what these are. So we can kind of read them out, but we can't do anything. So without execute permission in a directory, we're kind of effectively cut off from doing anything else, right? It kind of effectively cuts us off from a bunch of stuff. So what I want you to do is I want you to update the directory, our important directory, so that the owner has execute permissions. So I want you to keep read and write, right? I want you to keep the permissions how they are, right? I want you to keep the permissions how they are. So I still want read and write for the group, but I want you to add the execute permission for important, right? So what number, so we're thinking what number might that be? I want read, write, and execute for important. I still want to stay a read and write for the group, and I still want nothing for others. Okay, so I'm basically just adding execute to this.
For the owner, for groups? Or?
For the owner, just the owner. All right, so what did we get?
760.
760, right? Because read, write, and execute is a 7. Read and write, 4 plus 2 is 6. 0 for nothing. So chmod 760, important. And now, right, if we cd into, we can cd into it now. That's totally fine. We still have readability. That's fine. I can still read from the outside of the directory. That's all good. And now these file permissions are going to start taking effect because we could execute in the directory. Does anyone have any questions thus far about this directory permission? Why we needed execute? No? I need like a little chirp button. That's what I'm going to start hitting. The chirp, the cricket button. Cool. All right, so now let's go back to our home directory and let's take a peek again. Diary is a directory, right? Diary is a directory. It has execute for everything, but it doesn't have read or write. It has execute for everything, but it does not have read or write permissions, right? So if we have execute, we can effectively get into the directory, right? We can change into it. So everyone, let's change into the directory. Let's change into the diary. Yeah, that was fine. Diary had execute permissions, so we can get into it. But now let's try to list out some files in here. Permission denied. We don't have read permissions in this directory, so we can't even list out what files are in here. But guess what? We could still guess. Even though we don't know what's in here, you cybersecurity people, we can still take a guess. We might think of like, oh, okay, if you're a diary, right, what might be the name of a file in a diary? Entry, that's a good one. Anyone else? Day one, maybe? All right, so let's try to read. Let's cat out day 1. I can read the diary. Stuff happened that day, right? This guy's living a meaningful life. Stuff happened. He didn't want you to read it. He thought he'd taken away the appropriate permissions. He was like, nope, there was totally no read permissions in that directory, so no way that they can read something. It's all good. But he had execute permissions on the directory, meaning that I can cd into it, and now the permissions of the actual file itself take effect. So because I'm in there, the file permission takes effect, and guess what? That means day 1 still has read permissions attached to it. Even though we can't see its permissions because we can't list out anything in here, we get permission denied. Because that file still has read permissions, we're able to still guess what it is and read the file out. Okay? So that is permissions on a directory. Pretty cool. Any questions about what just happened there? No? Pretty solid? All right, cool. All right, so last but not least, let's CD up a level again. And let's look at this weird symbolic link looking thing. This guy. Before we get into groups, right? So before we get into groups, let's take a peek at this. And for anyone wondering, I'm not going to talk much longer. For those who are the first time here listening to me speak, We're almost through it. All right, we're close. So here we go. We have, it looks like full permissions to this shared directory, right? And it looks like it's pointing over here to this home EC2 user shared. Okay? And everyone should be pointing to the exact same one. Everyone has the exact same symbolic link. Symbolic links will always show up with full permissions. Okay? And we're going to talk about why that is slightly later, little prelude. But let's try to change these file permissions. You might automatically think, well, why are we not going to be able to change these file permissions?
We don't know.
Because
We're not the owner. So we can't change file permissions we don't own. So even if I try to chmod like 444 shared, not operation not permitted, you are not the owner of this. But we can CD into it, which is pretty cool for a symbolic link. Everyone CD into shared. And I thought it wasn't blank. Is everyone's blank?
Yeah.
Dang it.
no, we get I guys.
Oh, because Meetup 32 just made one. So touch a file. Everyone touch the name of a file, and you'll see that because this is a symlink and everyone's linked to the same directory, at the moment we are all creating files in the exact same directory. So,
We got rid of the cheese dip recipe.
yeah, someone deleted my cheese dip. There was cheese dip in there, and one of you deleted it. All right? It was a beautiful recipe. It said, number 1, get cheese. Number 2, melt cheese. Number 3, enjoy. All right? That is the perfect recipe for cheese dip. If anyone, all right. Dang it. So this is a symbolic link. We all have...
That's a lot.
I'm going to stop reading out this file because I feel like someone's going to be cheeky. All right, so we're not going to put that on the group, on the YouTube. Okay, cool. So let's talk about this groups thing. If we have no more questions about the chmod file permissions for owners, for others, we did a little bit of the group stuff, but we haven't changed our group yet. So does anyone have any questions about anything thus far? Yeah, Bruce.
In terms of changing permissions on files that you don't own, like how secure is that? Is it like
You can't.
that's it? Like clear cut, it's never gonna happen.
You can't. You must be root to change file permissions to a file that you do not own. Right? You can only change file permissions to files that you do own unless you're a root. Root can do anything. Right? Root can do anything. So that's why we never want to give out root credentials. Period. All right? Because then they can do anything. Doesn't matter what they are. Cool. Any other questions?
Actually, so much so you never really want to be in a root account in a machine unless you need to be. So if you own a machine, you create a root account, but you make like a super account or something, so you don't act as root.
Right. We try to never log in as root either. Right? Joe, do you have a question?
Yeah, like it follows on like, can you become root? Like,
You can become root. You can log in as root, but we try to never do that. What we are going to talk about slightly later, everyone's jumping the gun and I love it, is we're going to talk about sudo, right? Why we use sudo, what sudo is. And sudo allows us to become root for a moment, right? For a moment in time, we can sudo to become root, but we try not to ever actually log in as root. Okay? Cool.
Yeah, can I ask a quick question unless you know?
Yeah, no, go.
Does anyone know where those numbers come from?
the binary.
Yeah, so it's a binary, so you can always get the numbers out, right? If you look at there's 3 bits for read, write, and execute, right? So execute, write, and read. And the rightmost bit is 2 raised to 0, which is 1, right? And you've got 2, and then you've got 4. So you've got 4, 2, and 1. And then that's how you get that, right? So 1 is execute, right? So if you turn that bit on, it becomes 1, it's execute, right? Your 4 is write, your 2 is write, and your 4 is read. And if you add those together and you look at the binary, that's what's actually happening when you actually use those numbers.
Cool.
If it doesn't make sense, see us later.
Is that, so I guess that's similar because any number 0 to 7, if you know it's a number, you can reverse engineer the functions.
Yeah, exactly. So, you know we had read, write, and execute? So this is 2 raised to 0, this is 2 raised to 1, this is 2 raised to 2, right? Which is 1, 2, and 4. right? So that's why behind the scenes it's just looking at bits, right? It's just taking that and it's you're providing the number, it converts it to binary and then actually sets it based on that. So when you do a 777, right? 7 is everything is on, right? So that becomes this. So that's why you never do that, because it makes everything accessible to everything, which is you don't want. Right? So this is that octal number system, right? And you've got then 3 groups of it, which Garrett's just going to cover right now.
Yeah.
So your other, user, and your owner, other, and group. So that's where those numbers are.
All right. So in Linux, a user has the ability to belong to one or many different groups. Okay? So we can all view the groups that we are currently associated with by typing in the word groups. And I have assigned everyone to the members group. Everyone should have a members group, and they should also belong to themselves. Meetup, whatever, 1, 2, 23, whatever it might be. Okay? So this is a super handy command because one of our programs, like such as our web server or something like that, might be running as a different user, right? So especially when PHP and Apache is involved, Apache runs as a user www, right? And so it's running as a very specific user in Linux. And if we ever run into like write permissions when we're doing with PHP and Apache and stuff like that, it's most likely because the www user doesn't have write permissions to that specific directory. And this is where you get a lot of the chmod 777 stuff come up, especially in like Stack Overflow and things like that. It's mostly to do with PHP and Apache. It gets a bad rap, all right? It's near and dear to my heart, so don't talk smack about it, okay? But that's because they don't realize that the Apache web server is running as a different user. It's running as the www user, and then it's trying to write to a file. Like when we upload a file to the web, it's trying to write to a directory that it doesn't have permission to do it. So instead of actually changing that directory to be 777 so that Apache can write to it, what we can do is we can just add the www user to the group that is attached to that directory. We don't actually need to give it 777 permissions, all right? So groups is cool, but it doesn't give us as much information as you would like it to. We can also check out the groups for other users. So I could check out groups for the root user, and I can see that root only belongs to itself and root. I could check out the groups for the Meetup 2 user, and I can see that the Meetup 2 user is part of Meetup 2 and is part of members. So you can check out different groups for the different users on the system and what they're currently in. Now, if we want even more information, instead of using group, we can use a command called ID. Okay? This gives us all the information that we'd ever want. All right? So number 1, it tells us who our user is. Our current user ID is Meetup50. It tells us who our primary group is. This is our primary group. Guess what primary group means? It means when you create a file, that is the group that's going to be assigned to that file. Okay, that's the primary group that we belong to. And then over here, it lists all the groups that we're a member of. So it has our primary, and anything not the primary are called secondary groups. All right, all the other groups that we belong to. So ID gives us all that extra information. So once again, if we were to touch a file, so let's touch my group. And we'll list it out. Because my Meetup 50 was my primary group, guess what? Meetup 50 is assigned to this file. We've seen this before, right? We were just checking this out. So, however, any file that we own, we can change the group ownership of that file. We can change the group ownership of that file as long as, number 1, we own the file, and number 2, we are also a part of the group that we are going to change the file to. Okay? So we're all part of members, right? So we can run the command chown, which is change ownership. Change ownership for chown. And the owner is still going to be us. So whoever your user is. All right? Whoever your user is. And then colon, and now it's going to be what is the group that we now want to assign this file to. And let's all do members because we're all part of the members group. and let's assign it to the my group file. So we're going to change the ownership. We're saying we are still the owner, so it needs to be meetup-u, whatever number you are. We're going to go to the members group, and we are going to assign that to the my group file. And I'm going to click enter, and yes, that worked. So now when I look at it, we can see that the owner of this file is meetup50. The group that it's now a member of is members. Okay, so it's now a part of the members group. And we were able to do that because we were also part of the members group. What was the root group part of? Or sorry, what was the root user? What was his group? Root. All right, let's see if we can do that. Let's see if we can change this file to be, instead of members, root. Are we a part of the root group? No. Operation not permitted. Can't do it. Right? So if you are not a part of that group yourself, you cannot change the group to that. So you have to own the file, number one. Number two, you have to also be a part of the group to be able to do it. Also, the other thing that you need to know with Chown is you cannot give away ownership. I cannot give away ownership. For example, I can't do this. I can't be like, okay, so it's going to be part of the members group, but you know what? I want Clem to own it because she's member 3. I can't do it. I cannot change the primary owner of a file. I can't give it away. Does anyone know why that would be a security risk if we could give away these files to different owners, to different users?
You do something malicious and then point the trail to someone else.
That's actually a great, that's a good one. So I could have like illegal content or like unsavory content in a file, and then I could say give it to Ari up here, and then when the business comes looking around like, ooh, who was stealing our stuff? It's like, ooh, Ari owns all these files, right? That probably wouldn't be good, right? So we can't give away ownership like that. Another thing is a lot of times in these Linux systems, especially if we are on a shared host, they have data limits, how much disk space that they can have per user. So I could totally like fill up someone's disk space so they couldn't read or they couldn't write any more files. I just like, nope, just gonna fill you up with garbage, basically. The other thing that could happen is, so we have binaries on these computers, right? We have programs that we can run like ls and chmod. SSH is one of those binaries. So what I could technically do is I could give away my SSH binary. I could make a copy of it and change its ownership to be root. I could give it away to root. Guess I still know the password for that SSH, right? My password was still meetup1. So even though I've given away my SSH to root, I could now effectively log in as root to this system by doing that, all right? Which wouldn't be good, right? Because now you could totally have permission to everything. So that's why we're not allowed to give away ownership of our files in Linux for those type of vulnerabilities. Yeah?
What's that first option used for then? Like if you type your group, then where you're moving to?
Yeah.
Is that an option or is that just mandatory?
So we can change ownership if we're root, right? So if you're root, you use chown. There is another command besides chown called chgrp, which is change group, where you don't actually need that front part. But I don't see change group. The reason I'm showing you chown is I don't really see change group a lot on like Stack Overflow and stuff, right? Normally you see chown a lot more. So I wanted to explain that one more in depth than the other one, because this is the one you normally see people throwing around all the time, right? So this is the owner of the file. This is the group that the files you're trying to assign it to, and this is the file or directory that you are trying to change. Cool. Does anyone have any questions? All right. Are you cool for like 2 more minutes? Because I want to explain sudo and I want to explain a symbolic link. All right. Is that cool? All right. Sweet. So sudo, we already talked about it. It's basically the sudo command allows us to run as the root user. If I tried to sudo right now, guess what? I don't have that type of permission. So I can't be like sudo chown 777 the diary. Whoa. Okay. It says, we trust you have received the usual lecture from the local system administrator. It usually boils down to these 3 things when you're using sudo. Respect the privacy of others. Think before you type. With great power comes great responsibility. Programming humor, Linux. Thank you so much for that. Basically, it wants me to type in my password. And if I try to type in my password right here, whoops. I did not type that in correctly. Meetup-50. it says meetup 50 is not in the sudoers file. This incident will be reported. Basically, I don't have sudo permissions, and now it has been reported to the people who do. They can totally get in there and go, hey, meetup 50 was trying to sudo, right? He was trying to do some shady stuff in the system. You should look out for him. So basically, there is a file on our computer. It's this one right here. What's it called? It's called sudoers. This file right here, this in etc sudoers, it's the file that keeps track of who's allowed to be sudo, who's allowed to run as root at any given time. And notice that the owner, root, can read this. The root group can read this, and because we are other, we can't do anything in this file. So we can't maliciously add ourselves as a sudo person, right? So that is sudo. Once again, we never want to log in as root. Instead, if we want to give someone administrative permissions, we just add them to this file, and now their user can sudo, all right? The main point of that is that it still keeps track of who's running those sudo commands. So if someone is maliciously running sudo as an administrator, I can still track down who has run what commands and go, oh, it was Bryce, running a sudo when he's the guy that deleted that directory. Or, it was Nan, she's the one that installed that virus, right? I can see that stuff if I do sudo. Yeah. Bryce.
To run those commands, you need to know the password to get into sudo, right?
It's the same password as your user.
Yeah. Okay. So you can just see them being denied. That's what you said.
Right. Yeah. I can just see them being denied. Any questions about sudo? All right. Cool. Last but not least, the symbolic link. All right. So I'm going to cd back into my home directory. It's a tilde for anyone who doesn't know that. So I'm going to cd back into home. Last but not least, a symbolic link, or as many refer to it as a symlink, is more than just a shortcut. It actually makes it seem like that file is actually there for the computer. And that has many uses, but the main ones are you can access a file without creating multiple copies. We saw that. We were all in the shared directory. Everyone was creating files. We all had access to each other's stuff. It was beautiful, right? It was awesome. Cool. Another thing that allows us to do, it allows us to move our files to like a secondary hard drive, secondary storage space, without disrupting programs that need a path to be accessible from the primary hard drive, from the current disk space, right? So it allows files to find things in different places on our computers through the symlink, right? Which is really, really cool. So let's make our first symlink. So we have that my file that we all created, right? So if I list it out, everyone should have that my file. Yeah? If you don't, please create that file. And the way that we create a symlink is ln for link, -s for symbolic. Then we say, what is the file that we want to link to, right? So we basically want to link to my file here. So we're going to link to that file. And then the next part of this command is, where do we want to put this symlink at, right? Where do we want to put it? What do we want to call it? We can put it anywhere we want. We can call it anything we want. Let's just stay in our current directory, and let's call it like linked file. And we'll click enter. And if we take a look now, we now have a symlink, a linked file that is linked directly to my file. So we have linked file directly linked to my file. So if we add some content to my file, all right, let's do that. Let's add some content. So we're going to echo, and let's just put in whatever text you want. I'm going to just put in some text, and I'm going to put that into my file. So I'm putting some text into my file, okay? And I'm going to click enter on this, and now I'm going to cat out the linked file. Guess what? It's linked to my file. So even though we're catting out the linked file, it's basically catting out whatever we're symlinked to, which is what we just put text into. We put it into my file. So even though we're catting out linked file, it's printing out the context from my file, right? Because that's the link. That's what it's actually linked to. And you'll notice something again. What does it look like it has? Full permissions. It looks like it has full permissions. Okay? Don't let this trick you. I want you to change the permissions on linked file so that it has no permissions at all. None for the owner, the group, or other. I want you to change linked files permissions so that it has nothing. All right. So what would that be? 0, 0, 0 on the linked file, right? Cool. So if I ls-l, what does my linked file have? Oh, it still has full permissions. But what file is it linked to? What permissions does my file now have? You changed my file's permissions. You changed the file permissions that this symlink was attached to. Okay? So the symlink will always use the permissions of the file that it is attached to. When you chmod linked file, you're technically chmodding my file. Alright? The linked file will always show up. The symbolic link will always show up like full permissions like this. Alright? This is one of those gotcha moments. Where you're like, I can't get rid of full permissions on the link. Or it's, you can't see it. So now we have no permissions. If I try to cat that out again, if I try to cat out my file, nope, permission denied. If I try to cat out linked file, permission denied, even though it looks like it has full read, write, and execute permissions, because we're actually using the one on my file. Any last questions? That's it for my content. Thank you for coming to the meetup. But do we have any questions before we clap? Yeah, Clem.
Is all of this the same in the Mac terminal?
Yes. So Mac runs, it's not pure Linux, but it runs Linux-like software. So Mac has all the same stuff.
Okay.
Yes. Cool. Any like Linux distribution, like Ubuntu or Fedora or whatever that might be, it all has the same stuff. Even Unix is a lot like this. Linux actually is taking its file permissions from Unix systems. So even if you're working on a Unix system, 99% of it's going to translate as well. Okay? Cool. So any other questions? Awesome. I appreciate you coming to our first meetup.